Hello.
Ha, good morning, madam. Hello, 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 hello. Okay, yes, thank you. Mm.
Hello, sir.
Ha, hello, hello.
Yes, sir. Good morning.
Ha, good morning. Ha, let us
Yes,
start.
good morning, sir, and welcome to this first lecture of this academic year, first adjunct faculty lecture of academic year 24-25.
Thank you.
Today, we will conduct the session for the B instrumentation.
Right.
Okay, sir. Sir, you can start your session.
We can start.
Yes, yes, sir. Yes, yes.
Acha, just a minute. So, good morning, everybody, and I'm thank you once again for sparing your time. Today's session basically for final year students, and I hope they will understand the automation system in the industries, how it is working. And today's session, we will cover one of the reputed manufacturer, that is Emerson, and their product means a DCS product name actually is a DeltaV. However, DeltaV has so many versions of the controllers, software versions are coming up, but the name itself is a DeltaV. This is a brand name for Emerson for automation system. So that is the DeltaV, and a very easy to understand, a very popular system. So we will discuss today on what is the architecture, features, how it is installed, how it is working, and briefly about applications in the industries. Actually, we'll see the how install in the systems in the final stage of our presentations. So let us start. I'm skipping few slides because you are aware. So if you see the Emerson DeltaV DCS architecture, the system is in the control room, and as you know, field instrumentation and control room, there are two parts. So we will discuss control room systems and field separately, how it is interfaced to the field. So in the control room, mainly you can see operating staff, operating personals are there. They are basically chemical engineers, diploma, BScs. So they depend on the level of their professional level, but these people are operating the system, operating the plant, and automation background system is maintained, installed. Everything is done by configuration, graphic development, everything is done by instrumentation engineering part department of that particular process plant. So if you see the control room, there are operating stations. We will show you two. There's a basic, but that depend on the size of the process plant. That operator stations will be more, but this is operator station, engineering stations, and these two stations give the graphic user interface of the plant, real time graphic user interface. Real time means the plant running, they are not moving in the plant, going in the plant to see the actual parameter values. They get actually real time values here on these screens. These operator stations are interface to the control systems or field, and that how it connected, that flow I am showing now. So first part of the automation system is a graphic user interface, and that is here name given is a engineering station and operation. The basic difference in the engineering end is that operator station has a operating softwares, means whatever softwares required for operation of the process plant. However, in engineering, you get operation as well as configuration, means graphic development or any loop adding, PID loop editing. So all these configurations part uh, or development part is done on this. So here there are more softwares are there. This station is very costly because you have engineering licenses on this along with operators licenses. So this particular station is used by instrumentation engineering department. However, these operator stations, as I told, depend on the size. It is a more also 4, 5, 6 stations are there in the plant, but the same softwares will be there. And these stations are connected on the network. That network in the DCS architecture is called control network. However, here this control network is a dual redundant. Dual redundant means, as you can see, A and B means A communication fails, B is always there, and this dual redundancy is there on the network side. uh, that is ethernet basically, but this is something different ethernet, that's IEEE 802.4 category. However, we use ethernet for our commercial or home purpose is IEEE 802.3. So this is a redundant, this has a redundancy. And for this network in the DeltaV architecture, Emerson has given a name is a high speed ethernet. However, Honeywell has different name. Though it is Ethernet, Yokogawa has different name. But here you under, because we are today discussing Emerson system, so the name is here high speed Ethernet, and this is a dual redundant. A is a primary, for example, B is a secondary network. And you see this, they both are connected. This is not like a positive or negative. Here, both are separate networks. However, A has a bunch of wires, plus, minus, send, resend, that will be there based on Ethernet requirement. Similarly, B has the same. And these uh, here it is represented not like this, but it is actually in the plant. It is a uh, implemented through switches, data switches, network switches we call, and these are also redundant network switches. A has one switch pair, B has different switch. I will show you that switches. But here I have not shown because we are discussing the architecture and functioning of the system. So in the Emerson DeltaV DCS, first card is a power supply card, which provides the power to the controller. Controller depend on the version is on 5 volt. Earlier it was a 12 volt, then 9 volt. Now it is coming on 5 volt. Like this, low power, high processing. Because of low power, the heating on the control side is less, so the reliability is more. Means the life cycle, if you see the controller, is more as compared to the earlier. So low power always gives a benefit. And new latest controller is also coming with a high processing power, as well as
more memories on this. So that depends on the semiconductor or electronic industry development. That advantage we get it here in the controller. But and here also name also get it changing. MD plus controller was there, now something else coming up after 4 years, 5 years. Every company is changing their product with a different name. So power supply card is a DC power to the controller, and this is the controller is the main device. Then you can see here uh, another power supply controller. This is again redundant. If suppose this power supply or this controller fails, the secondary is always there. So this is a primary controller. P means fire. This is a secondary controller, and both are getting connected on the network. You can see here. So in the Emerson DeltaV DCS, you can see engineering station, workstation, high-speed Ethernet, power supply card, controller card, redundant power supply, redundant controller, redundant network. So this is the way system has architecture in this. Now I am coming to the I/O cards, input and output cards. So in the Emerson system, uh, as I have told two wide power and control carrier means always you will get, suppose I want only single controller, so you will get only two wide power and control. This is the carrier. Carrier means backplane with you can replace the card like this. So two wide power and controller carrier and another two wide power and control means if you need redundancy, that becomes on the process point or process uh, requirement, how much process critical it is. So they based on that, redundancy is optional. But normally in the plants everybody takes it because this is one time entire thing is on the controller, so redundancy is always uh, preferred. But too wide means you have a backplane with the power card slot as well as controller slot, so that comes single. That's called two wide power. As I told, then another carrier is there, and which is also at this DIN rail. That is again, it is a standard 8 wide. Means you will not get like I want only AI and AO card, so I want only to carrier up to. No, you will get entire carrier with the 8 wide cards. You can fit, or that is optional. If suppose you have only AIAO, DIDO, you don't have RTD, RT, thermocouple, or Fieldbus or serial interface, then these slots will be empty. But carrier will be a standard 8 wide IO carrier. So you see here nomenclature. AI means analog input card, AO means analog output card, DI means digital input card, DO means digital output, RTD inputs means this is again all resistance means RTD, resistance temperature detector inputs are directly connected here without transmitter, thermocouple directly connected here without transmitter. H1 card is the name here given for foundation Fieldbus communication protocol devices, transmitters, control wall, that you can connect on this. Serial interface means this card is for serially connecting the devices like PLCs, analyzers in the plant. You can serially connect it. And, as well as now the technology is giving Ethernet connectivity also. But earlier it was a popular interface was a serial interface. Then Ethernet also now slowly came. Now wireless also came. So these are the developments happening. But serial is a most preferable as on today in the industry. So now you can see here, this is the basic architecture, very simple system. Again, I am repeating because I am on online mode, virtual mode. You are not in front of me, so I cannot ask questions, but this slide I think is more visible and very simple to understand. So I think I'm going ahead. So you can see IOs are getting connected, analog input, analog output. You see these are connected to the devices in the field. So they are routed through marshalling cabinet. So normally the cabinets are there and the names are given. For example, uh, if the plant is larger size, then there is a one cabinet dedicated to the system. So system cabinet, that is called. All this will be in the system cabinet. Similarly, IOs are more than IO cabinets, input output cabinets. Similarly, marshalling cabinet is also very important here, and through that your field connectivity or isolations, intrinsic SIP uh, devices, entire thing comes here in the marshalling part. And then you can say in the field, this multi-pair cable goes to the respective area JB. JB means junction boxes. So here JBs are shown. I will show the pictures, and for demonstration purpose, symbolically it is shown one transmitter, one control wall here. Similarly, this JB is indicating DIDOs, a switch as well as solenoid. This is a solenoid symbol, this is a switch symbol, this is a transmitter symbol, this is a control wall. So these are analog input output JBs. These are the DIDO, digital input output JB, that is shown. So this way, I think system is uh, there in the basic system. As I told you, it is a scaling will be there based on the requirement. Scaling means if you have more inputs, then more input output controllers will be more, because you cannot load entire plant on the single controller. Maybe you have 20 closed loops on one controller. So if in your plant there are 100 closed loops, so 4 5 controllers are the separate side. So I have explained the uh, this function of engineering come operator station. Uh, 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 some like Dale is standardized for all DCS vendors, reputed vendors globally for DCS, but always this configuration changes based on the uh, we can say the PC configuration changes like this. So this was a very old Windows XP. So now Windows XP is old, so it get changes. So this you forget, but this is latest Dell industry workstation. Like this, I just generalize it. Similarly, operator stations are also same hardware, and only softwares are getting changed. You can see a software operator workstation softwares. While here, professional plus workstation software means this is engineering plus operation. And this word is very important. 750 DST means actual tagging. The software is 100 tags, 200 tags, 500 tags. Like here, 750 tags is a requirement maximum. Suppose your plant require 500, so 250 more tags you can ask, because one time it is there, and the software is cost. Software cost is based on uh, your this one tag. So you can see your control network here, workstation. As I told, here primary switch, secondary switch, control. This way it is connected. You see this way. I told earlier the name was hub, but it is now a switch. So this is Ethernet cables from coming to different networks, primary and secondary, and this is a controller here. You see this way it is connected. 10 out of 10 oblique 100 BST cable. So the connector is also same. This is a standard. This is Ethernet accessories. Maximum length is 100 meters from this switch. That way you'll get a better access speed. Similarly, you can say 300 is a or 100. You can it is a normal near, but you don't go beyond that. Otherwise, you have to use a fiber optic. So actual look of the hardware, that was a demo. Just I have drawn this, but you can see here actual system look like this. You see here power supply card looks like this. This is a controller card. You can have more indication, diagnostic indicators. So this is a two-eyed carrier. You can I will show the carrier also. This is another two-eyed carrier, redundant power. So again, power supply. This is a controller, right? Then this is what I told, IO cards, analog input, analog digital, like this 8 cards you can see here. And these are the terminal strips which goes to the marshalling cabinet. And this entire back plane is called 8 wide IO carrier. Similarly here 2 wide IO carrier back plane is there. So this is actual picture. The delta V looks like. Suppose any card fails, you can replace by removing these screws. You can see everywhere the screws are there. This. Very simple to maintain it. You see here. Just to replace the card. That's all. And put a new card like this. This. And you can have extension of the IOs through this here. You can have cable is here. You can extend to 8 wide IO care more based on the requirements. So this is a connector for extension. So you see here um, slightly better picture. You can see here power supply card, power on healthy, and here on the MD plus controller you can see here power and which standby or primary, that indication is also there. And your network status means whether your A and B are working or not, like a high speed ethernet network is working or not. That is, so this is your active controller. You can see your indication active. However, this is standby, so you can see your indicator green, standby. And first one is the power on indicators for all, right? So then next card is a very important card is analog input card, and it's a 8 channel card because in this card you can see here again 8 indicators power for 8 analog inputs you are showing, and power indicator is there. So this LED indication for channels, mounting screw as I shown, and this is a terminal blocks for wiring. So the same is shown here actual drawing. 1 2 3 4 5 6 like this. You have termination for channel 1, this channel 2, channel 3, channel 4, channel 5, 6, 7 and 8, plus and minus, it is indicated. So you can simply wire here. This is what it is called IO terminal block, this one terminal block. And inside this card you can see electronics, means major electronic part, functional part is shown here. So you have a 24 volt DC because IO card requires 24 volt DC. As I told, control requires less power, 5 volt minimum. And you can see your just transmitter, one of this channel you have a one transmitter connected, team is transmitter which is in the field, and this signal plus minus goes inside the card. Fuse is there in the card, and then other processing like a current limiter, low pass filter. A to D is a very important. Main function of processing is analog to digital conversion. And then through isolations, this is called optical isolations. So you can see it goes to, signal goes to the controller, further controller, this through this. So this is what analog input card looks like. Similarly, analog output card, same, you can see 8 channels, mounting screws, LED indications, terminal block. You can see here actual wires are connected here. And same, you can see here channel 1, 2, 3, 4. And at this channel, channel number 15 and 16, it is shown over output is going. Digital output, sorry, analog output. And this analog output you can see here shown through load 4 to 20 milliampere device. This again analog output 4 to 20 milliampere goes, maybe goes to your further I2P and control wall. So from the system controller, signal is coming in the digital form. Again that signal is isolated. Then in this card, D2A is very important because analog output is coming out. So D2A converter is here. and other things are same, power supply. Only this card is having less electrons as compared to A to D. So the cost is more on the analog input card as compared to analog output card. Analog input card costing more, cost is more high than more cost than analog output card. Right, 4 to 20 million current source and all this. The next card is a digital input card. As you see, the digital input card for your interlocks, indication, monitoring, and it has a high density. Means it is a because is a processing is very less on the card, so you will get a card with the 32 channels. You can see here the card with the 32 channels, 1 to 32. Because in the digital, common is a one wire, so no, you have to connect only single wire. So you can see here channel 1, this switch is connected, and this is a common. Negative is a power common, and all devices common together. Means all your JBs, wherever this digital input outputs are there, the negative is loop with the power of the system. If it is not done, you may get a error. You will not get a signal value here, and error will be indicated on the card. Sorry, card, because it is having high density, so indication for the 32 channels are not there on the card. You will get a single indication wherever any channel fails. So in the 32 channel terminal blocks, line numbers are shown, and as I shown, the processing is done from this. This is a input card. So you just see here termination, IO card, isolation, power supply. That's all. Similarly, digital output card, you see here 32 channels. Again, from the system controller, signal is isolated, and you get here output low in the load format. And this way, wiring is done for this. So this is a 32 channel. Input is also 32 channel, and used for monitoring interlocks uh, in the process control. Now I'm going forward with the RTD input card. I mean, the resistance temperature detector module. Basically, this module, the function of this card is earlier. Suppose you have so many temperature maximum in the process temperature measurement. So lower side means the temperature is less than 2 300 or 500, we can say. Mainly 300 400 we use RTD, and higher temperature we go for thermocouple. So if you require analog input for any processing in the controller, PID loop, or no need to have a transmitter in this. So from RTD, then suppose this is 38 channel. So if you require 4 to 20 milliampere from this thermocouple or RTD, you require a transmitter, and then 4 to 20 milliampere you have to use analog input card. So to avoid that, for a non-critical input or loop processing, uh, these cards are used, RTD or thermocouple cards. For critical loops where PID is there and all, uh, normally AI and AO cards are used. Means wherever critical control is there, AI, these cards are used. You can see here this card RTD with a 2 wire, 3 wire, 4 wire is shown. See, for example, 3 wire is a common configuration. So 3 wires, how it is connected, it is shown here. It's a very simple, and you see here these wires. First sensor is because it's a 8, so sensor excitation plus is here of all 8 channel, minus is here, and this is a common circuit common. So this way it is a connected, this way, common, minus, plus, and based on this you can see a three wire you can connect like this. These two are shorted together like this, common and sensor minus means here sensor minus and common is shorted together like this. So this way it is easy to connect. Earlier it was you have to use hardware drawings and a lot of things. You have to check. However, this is very simple nowadays, user friendly we can say. So maintenance time is reduced and no error in the maintenance also. Similarly, thermocouple input card. Again, thermocouple you can see is a 8 channel, and you see here channel 1, channel 2. So in these two wires, you can connect thermocouple. Plus, this is thermocouple symbol, and you can see here is a plus, and this is a minus. Again, A to D conversion is required here. So wherever A to D is there, cost is more. You can see earlier also here. So here also A to D conversion curve like this is there. So now, as I told, the function of both the thermocouple and RTD cards is for non-critical monitoring and control. These cards are used maybe for operator requires indications only of different points in the process. So these cards are used. This is the Fieldbus card, and this Fieldbus uh, H1 card is here. As you are aware that in the communication protocols, when we see the evolution of the communication protocol, earlier we were using pneumatic signal 3 to 15 psi. Then we started using analog signal 4 to 20 milliamp. Then we switch now to the partial analog plus digital, that is hard signal protocol wise, which has a benefit of using a communicator for maintenance. Means you can communicate it directly in the field to the transmitter and do certain maintenance which before replacing. And here hard protocol is analog plus digital, so still we use analog values, wiring is same. However, in the field bus we have purely digital signal, so there are other benefits here. Networking of the devices and everything is possible in the. So if you have like networking, like ethernet networking, you can implement devices networking through fieldbus also. So this card you can see here, this is the picture of the card. And again you can, this has a two ports, port 1 and port 2. uh, so port 1 has suppose 8 devices and port 2 has your 8 devices. Like this you can connect 16 transmitters or 16 transmitter control walls together using this card by digital communication. Means digital signal, you understand, no plus minus wires are individual wires are coming from the field. So on a single wire itself you can have 16 devices getting connected to the your control system, and that reduces your cabling, and your installation time is reduced. Third thing, accessories also less required. And very important advantage is you can do the diagnostics maintenance of the field devices from your engineering station in the control room. So these there are a lot of benefits of this protocol. We'll discuss it later on because we are discussing DCS. So I'm just giving the picture. See here, uh, this is the H1 card here, and through this, nowadays it is coming through powered. Earlier it was required externally. You have require one card field power, and then it getting to the field, and this main cable, single cable, it is called a trunk cable, and in the field there is a junction box, this is not a conventional junction box. And through this junction box, like your network switch, and each device is connected, and then in the terminology in the this it is called a spur. This is spur. This is spur cable. You see here one transmitter, which is a fieldbus transmitter, getting connected to this junction box. Then another positioner getting connected to this. Then this is a controller positioner. This is another make Samsung. This is a Dresser, and even Fisher has also. This way it is getting it. So three devices it is shown, but this has a capacity of 8, or maximum you can go for 16. So getting connected there. So the direct you can say these wires are not coming to the control system through JBs and all to the cards. It is processed through this single card. So it is like our network switch. So serial card, I am just coming to the another very important card used in the Emerson or any DCS is a serial interface, and this is the card which is the mounted in this rack, and mainly it is used for, as I told, for analyzers PLC interface. So here you can see this is one analyzer unit which has also DC Modbus interface, that is RS485, and this is getting connected to serially like this. So with this card is here getting connected to the DeltaV station. So this is a what uh, third party devices other than Emerson getting connected with the DCS through Modbus. So serial interface card is also two ports. You can have two different systems. One port you can connect PLC, or you can connect another is analyzer, or you have a two PLCs like this. And these are the specification of card. As I told, specification getting always change based on the electronics. Uh, Number of devices, tags, and all it is mentioned. That is on the device side. So port type means RS232, RS422, 485 half duplex. This way you have configuration available. Uh, Even you can connect the wireless devices. You can see here wireless gateway is here, and which has serial interface earlier days. Now the wireless devices are getting connected through Ethernet. Hmm. So you can see the wireless device, wireless transmitter getting access to the gateway. Gateway is a serially, so you can connect on serial interface card like this. So this is what system looks like. This is the function of serial interface card. So I will coming to the analog in a closed loop. Now I will show you closed loop analog signal implementation. Field transmitter, two wires plus minus, junction box. This is junction box, marshalling cabinet, and in the system in the control room analog input card, one of the channel, right? Then this signal is getting in the digital format to the controller configuration, whatever PID configuration. Output goes to AO, one of the channel. From the AO, analog output card one through the channel goes to the marshalling cabinet, and then goes to JB. Okay, means this is the what field, this is what control room, and as this is output. So as I told, 4 to 20 milliampere I2P, and this is the control wall. So this is where the any closed loop analog signal implementation is done, uh, and this way it is operating, working. So I think this is then controller is getting connected on high speed ethernet with a workstation. So actual values transmitter or what is the controller status getting here on the graphic user interface. So human machine interface or graphic user interface here. So same signal, I have taken one loop drawing, and with the tagging LT means level transmitter loop number is 102. Then JB is here 01, where it is terminated at 2223 terminal number on the junction box terminal block, because the block is terminal strip, normal terminal strip, so but numbering is there. So this drawing is very important for you for maintenance. Then these wires from JB is a multi-pair cable. This is not a single for transmitter, so it is carrying maybe 12 devices, either input or output. And this cable coming to the marshalling cabinet. And this particular transmitter wire is here in the marshalling cabinet terminal strip 1 and 3. It is terminated, connected. And then you can see here further part here, this is a rack which where the AI card is there in the rack 1, slot 3, and channel. The meaning of that, as I told, in this rack 1 means you have one rack, 8 wide IO. So there, third slot, this card is there, and the channel number was 1. Then AO, then the signal is coming here to the controller, digital signal. Controller process your loop, displays on the workstation, operator station, engineering station, and the output goes to the AO card. And the AO card is in the rack 2, another rack, uh, slot 3. Just understand rack and slot, and channel 5. And then it goes to the marshalling cabinet, terminal number 9 and 10. And then this multi-pair global goes to field JB, same JB. So I think the same wires are here. See, by 22, 23, and 26, 27 in the same JB, because these are very near in the same area of the plant. So the wiring is done accordingly. And this I2P tag is LY102. And finally, this is your control wall, that is need air supply. Output required, output of the I2P is a 3 to 15 psi, and this is a level control wall in the field. So entire loop which you have shown here, how it is a functioning is shown here, but actually it is a, this is actual drawing. And through this drawing, engineers get to know which transmitter, where it is connected, and suppose any transmitter maintenance is required, or any maintenance or replacing this, then you know the JB number where to connect, and all this. So this drawing is very very important for you. So closed loop digital signal implementation, you can see here. Now we have seen analog. Now digital use here. Digital is a temperature switch, JB in the field, marshalling cabinet, and DI in digital input card. Goes to, for processing here, MD plus controller. Output goes to digital output card. Then marshalling cabinet. Then JB, and here solenoid wall. So digital closed loop, you will find digital input and digital output. So switch is input and solenoid wall is output. So in this loop, you can see JB marshalling. Yeah, the picture in the processing is done through DIDO and controller, and then through high-speed Ethernet on the workstation, you will get a status of your switch and solenoid graphically. So same loop you can see here, nomenclature here, LS for switch 102. Sorry, then JB 1, then marshalling cabinet, DI card in the rack 1, slot 3, channel 1, controller, DO card, rack 2, slot 3, channel 6, like this. Marshalling cabinet, JB. Digital output card again, rack 2, slot 3, and channel 1. Sorry, channel 5. And then marshalling cabinet, JB, same JB, wire number 26, 27. And this is what your electrical signal goes here. That is a solenoid wall. So this way your closed loop is Digital closed loop, discrete closed loop is represented in terms of the drawing. I will show you the installation of this one of the plant. This is ammonia plant where we have three systems working. Because main is Yokogawa, then Emerson is for some other section for compressor, Honeywell system like this, and all together connected. Uh, I mean, the control room is a single nowadays. So I'm just skipping some part which is not relevant because I'm just showing the plant name is a PGR means organ plant, and this organ plant means PGR, post gas recovery plant. You can see the system architecture here. How it is connected to the ammonia plant, that is through fiber optic. So the main system is here actually. Here, this is the system in the organ plant where you can see same architecture, power supply controller. But here the cards are you can see here AI card 8 channel 6 numbers, AO card redundant 8 channel 6 number, AI card without redundancy 16 channel 7, AO card 8 channel 5, DI card 32 channel 3, DO card 32 channel 2, RTD 8 channel 14 cards. You see how much RTD inputs are used, and serial interface card 1. So these are the cards required in this plants. So this is the capacity of the plant, that PGR plant. So this is the PGR system, this one. And as I told, power supply controller, and these are the IO cards, AI, AO, DI, DO, serial. So argon control room. So you can see here, this is system picture. Controller is here, racks are there, cabinets here, and this is a workstation through ICC. Fiber optic switch getting connected to the main control room because the plant distance is more than 300 meters. So as I explained you, number of cards 12, AI, AO card 12, DI card 3, DO card 2. I'm on a plant here. You can see the picture. So now I will show you one loop here. Hmm. Dila. Pressure monitoring loop is a pressure transmitter, junction box, marshalling cabinets, display IO cards, and workstation. So this way, one product is because argon is used for welding and chilling. So you can see the argon gas coming out of this. So it is chilled and ice formation on this. So uh, this is what loop is shown. Pressure transmitter, junction box. So this is a pressure transmitter field. Junction box. So I will show you one by one. Pressure transmitter is here. You can see JB number and all other tool numbers. And this is the JB with covered with the various cables, input output. And this is a multi-pair cable. Thick is a multi-pair cable like this, which goes to the marshalling cabinet. So this is the marshalling cabinet. This one. If it is open, you can see
Hello,
this.
sir.
Hello. Hello.
Shall we continue remaining part tomorrow?
Yeah, yeah, definitely.
Okay, okay.
Thank you. Hello.
Yes, sir.
I'm closing then. All right.
Yes, yes, yes.
Thank you, madam. Thank you. Thank you.